Welcome friends. In this video, we shall learn the topic how to convert a non-terminating repeating decimal expansion into a rational number of the form P over Q. And we shall learn this topic by an example. And this example consists of 4 parts. This is fourth part of the example. And we have to convert all these non-terminating repeating decimal expansion in P by Q form. Let us see how to do it. We shall start with part 1, and part 1 is given 0.1 bar, and we shall let that this value 0.1 bar is equals to x. Then we can write this 1.1 bar like this, 0.11111, and let this is equation number 1. Now we shall multiply both the sides of this equation 1 by 10. If we multiply x, then we get 10x. If we multiply this number, then this decimal point will move one place to the right side, and so we can write it 1.111 dot dot dot, and let this is the equation number 2. And now we shall subtract equation 1 from equation 2, and if we subtract equation 1 from 2, we get x 10x minus x equals to 9x, and the decimal part of these two numbers are same. So if we subtract 0 from 1, we get 1. So 9x is equals to 1, therefore x is equals to 1 over 9. This means 0.1 bar is equals to 1 over 9. So this is the solution of the part 1. And now we shall move to the second part of the example, and the second part is 0.115 bar like this, and we shall let that this value is equals to 1 equals to x, and we can expand this 15 bar like this, 15 15 15 and dot dot, and let this is the equation number 1. First we shall multiply equation 1 by 10. We get 10x equals to 1 point, because this decimal point will move one place to the right side, then it will be 1.51515 dot dot. And what we observe that the digit just after the decimal point is not same in these two numbers, so we shall multiply once again by 10 equation 2 both sides. We get 100x, and the decimal point will move one place once again to the right side, then it will be 15.151515. And what we observe now, we observe that the decimal part of this number, this equation and this equation are same, so we can subtract equation 1 from this equation 3, and if we subtract 1x from this 100x, we get 99x, and if we subtract 0 from this 15, we get 15. So the 99 is equals to 15, therefore x is equals to 5 over 33. Therefore 0.15 over bar is equals to 5 over 33. Now we shall move to the third part of the example, and third part is 0.23 bar, and bar is on 3 only, not on 2, you can observe. And now we shall let that this value is equals to x, and if this value is equals to x, therefore x will be equals to 0.2333. Only 3 will repeat, because bar is just on 3. So we let this is equation number 1, and we shall multiply this equation by 10. We get 10x, and this decimal point will move one place to the right side, so it will be 2.3333 dot dot dot, and that this is the equation number 2. And now what we observe that the the digit just right to the decimal point in these two values are not same. Here is 3 and here is 2. So we shall multiply once again equation number 2 both sides. We get 100x equals to 223.3333 dot dot, and let this is the equation number 3. Now what we observe that the decimal part of these two values are same, so we can subtract equation 2 from equation 3. So on subtracting equation number 2 from equation number 3, what we get? 10x 100x minus 10x means 90x, and 2 minus 23 minus 2 means 21. Therefore x is equals to 21 over 90, and we can cancel out these values by 3. We get 7, we get 30. So x is equals to 7 over 30. This means 0.23 bar is equals to 7 over 30. Now we shall move to the last part. This means fourth part of the example, and fourth part is zero point 123, and bar is just headed on the head of 3. And now we shall let that this value is equals to x, then x can be equals to 0.12333 dot dot dot, and let this is the equation number 1. And now we shall multiply both the sides by 10. We get 10x equals to 1.23333 dot dot dot, and let this is the equation number 2. Now once we shall once again multiply this equation 2 by 10, we get 100x equals to 12.3333, and like that this is the equation number 3. And we observe that the decimal part of these three equations is still not same, so we shall multiply once again by 10 equation 3 both sides. We get 1000x equals to 123.3333, and now the decimal part of these equation number 3 and 4 are same, so we shall subtract equation number 3 from equation number 4. On subtracting equation number 3 from equation number 4, what we get? We get 900x equals to 111. This means 111. Therefore x is equals to 111 over 900, and we can cancel out these values by 3. We get and this is equals to 300. So this is therefore 0.123 bar is equals to 37 over 300. So this is the method how we can convert a non-terminating repeating decimal expansion into a rational number of the form P over Q. Thank you.